Right now, as you sit there perfectly still, you are moving faster than a rifle bullet. You don't feel it. You can't feel it. But the ground beneath your feet is racing through space at over 1,000 miles an hour, carrying you, your house, your city, the oceans, and the very air you breathe along with it. This is the great unnoticed truth of your existence. The planet you call home is a spinning top, and you have spent every single moment of your entire life riding its surface at supersonic speed without ever once spilling your coffee. Now hold that thought. Hold it tight, because I want you to imagine that in a single heartbeat it stops, not slows, not winds down gently over centuries, stops. The earth itself slams to a halt while everything resting on it keeps moving. The coffee in your cup, the car in your driveway, the skyscrapers, the mountains of loose soil, the entire ocean, and every molecule of air in the sky suddenly become projectiles, still hurtling eastward at the speed they were a fraction of a second ago, while the rock of the crust simply refuses to come with them. What happens in that instant is one of the most violent events the human imagination can conjure. And what comes after, if anyone could survive to see it, would be a planet so alien that you would not recognize it as Earth at all. So let's do the impossible. Let's stop the world. And let's find out, second by second, hour by hour, century by century, exactly what would happen if the Earth suddenly stopped spinning. Before we break the world, we have to understand how it works while it's still whole. The Earth spins on an invisible axis, an imaginary line running from the North Pole to the South Pole, and it completes one full rotation roughly every 24 hours. That single rotation is what gives us day and night. As your part of the planet turns to face the sun, you get morning, noon, and the warmth of daylight. As it turns away, you get evening, midnight, and the cool darkness of night. It is the most basic rhythm of life on Earth, so fundamental that every living thing, from the largest whale to the smallest bacterium, has built its biology around it. But here is the part that almost nobody stops to think about. Because the Earth is enormous, that gentle once-a-day spin translates into staggering speed at the surface. The planet is about 25,000 miles around at the equator, and it covers that entire distance in a single day. Do the math, and you find that a person standing on the equator is being carried through space at roughly 1,040 miles per hour, or about 1,670 kilometers per hour. That is faster than the speed of sound. You, or someone living near the equator, are right now traveling faster than a passenger jet at cruising altitude, faster than most bullets leaving the barrel of a gun, and you feel absolutely nothing. Why don't you feel it? The answer is one of the most beautiful ideas in all of physics, and it is the key to understanding the entire catastrophe we are about to unleash. The reason you feel nothing is that everything around you is moving at exactly the same speed. You, the chair, the air, the building, the ground, all of it travels together in perfect unison, like passengers in a smoothly cruising airplane who can stand up and walk down the aisle without being thrown to the back of the cabin. As long as the speed stays constant and steady, your body has no way to sense the motion. It is only change in motion, acceleration, or sudden stopping that you can feel. When that airplane hits turbulence or slams on the brakes, suddenly you feel everything. And that is precisely the principle that turns a stopped Earth into a global apocalypse. The danger was never the speed. The danger is the stopping. This is the single most important concept in this entire scenario, so let me make it absolutely clear with something you already know in your bones. Imagine you're riding in a car going 70 miles an hour down the highway. You feel comfortable, relaxed, maybe even bored. Your body is moving at 70 miles an hour, but so is the car, the seat, your coffee, everything. Now imagine the car hits a concrete wall and stops instantly. The car stops, but you do not. Your body, obeying the most stubborn law in the universe, the law of inertia, keeps moving forward at 70 miles an hour until something stops it, which is exactly why seatbelts and airbags exist. The wall didn't hurt you. Your own momentum did. Now take that exact same physics and scale it up to 1,000 miles an hour, and apply it not to one person in one car, but to everything on the surface of an entire planet at the same time. The ground, the crust of the earth, hits its metaphorical wall and stops. But you, your house, the trees, the oceans, the atmosphere, every loose object and every living creature, all of it keeps moving eastward at 1,000 miles an hour. There is no seatbelt big enough. There is no airbag for a continent. In that single instant, the surface of the earth becomes the most violent place that has ever existed. So let's witness it. Let's stand on the surface, somewhere near the equator, in the moment the world stops. For the first fraction of a second, nothing seems wrong. The sun is in the sky. The wind is in the trees, and then the crust stops dead and physics takes over. You and everything around you that is not bolted into solid bedrock are launched horizontally toward the east at over 1,000 miles an hour. But it is so much worse than just being thrown. 1,000 miles an hour is supersonic. You would not gently tumble. You would be flung eastward faster than sound itself, smashed and scattered across the landscape in less time than it takes to blink. Buildings would not topple. They would explode off their foundations and disintegrate as they were ripped from the bedrock and hurled sideways. Bridges, vehicles, entire forests, the topsoil itself, the loose upper layers of the ground, all of it would be sheared off and sent skidding and tumbling and shattering toward the eastern horizon in a churning wall of debris. The landscape would be scoured clean in seconds, planed down to bare rock as everything loose on the surface was wiped away by its own momentum. Mountains made of relatively loose material could shatter. The only things that might remain anchored would be the deep bedrock and the roots of the planet itself, the parts truly connected to the body of the Earth. Everything else becomes a projectile. And remember, the speed of this catastrophe depends entirely on where you are standing. The Earth's rotational speed is greatest at the equator and decreases as you move toward the poles. This is simple geometry. A point on the equator has to travel the full 25,000-mile circumference of the planet in one day, so it moves at top speed. But a point near the North or South Pole barely moves at all, because it's so close to the axis of rotation that it traces only a tiny circle each day. So the devastation would not be uniform. At the equator, the surface stops from over 1,000 miles an hour, the maximum carnage. At a latitude like that of the southern United States or southern Europe, the ground was moving at perhaps 800 or 900 miles an hour, still catastrophically, lethally fast. By the time you reach the high Arctic or Antarctic, near the poles, the rotational speed was only a few tens of miles an hour or even less. So in a grim and almost unbelievable twist, the only places on the entire planet where you might physically survive the initial instant of the stop are the regions immediately around the two poles. Everywhere else, in a single moment, becomes an unsurvivable storm of flying earth and disintegrating civilization. But the flying debris is only the opening act, and it is not even the deadliest part. Because there is something on this planet far more massive, far more dangerous, and far more impossible to stop than buildings and forests. There is the ocean. The world's oceans hold an almost incomprehensible amount of water, more than 300 million cubic miles of it, and every drop of that water has been spinning eastward right along with the planet at the same supersonic speeds. When the Earth stops, the ocean does not. The water in the seas keeps moving, a planet's worth of liquid carrying the full momentum of 1,000 miles an hour, with nothing to hold it back. The result is a redistribution of water so violent and so vast that the word tsunami feels almost insultingly inadequate to describe it. The oceans would surge eastward, piling up against the eastern coasts of continents in waves that would not be measured in tens of feet, but in thousands. We are talking about walls of water taller than mountains, sweeping inland for hundreds, even thousands of miles, drowning entire countries in minutes. The eastern seaboards of every continent would be obliterated under an ocean that suddenly had somewhere it wanted to go and nothing to stop it. Coastal cities, inland plains, mountain ranges far from any shore, all of it would vanish beneath an apocalyptic flood as the seas of the world tried to keep moving while their basins held still. Water would slam into the western faces of mountain ranges, recoil and slosh back in titanic standing waves that would take days to settle. There would be no high ground high enough, no shelter far enough inland. The very shape of the continents, the basic geography of land and sea, would be rewritten in a matter of hours by the unstoppable momentum of the world's water. And still, we are not done with the destruction. Because there is one more thing on this planet that was spinning with it, something so all-encompassing and so easy to forget that we breathe it without a second thought. The atmosphere, the air itself, the entire envelope of gas that surrounds the Earth, every cloud, every breeze, the oxygen in your lungs, all of it was rotating eastward with the planet at supersonic speed. When the solid Earth stops, the atmosphere keeps right on moving. And so the entire planet would be scoured by the most extreme wind the world has ever known. Imagine a wind blowing at over 1,000 miles an hour, supersonic, screaming across the surface of the Earth without pause. Hurricanes, the most powerful storms our planet currently produces, top out at around 200 miles an hour. This wind would be 5 times stronger, blowing everywhere all at once across the entire globe. Anything that somehow survived the flying debris and the impossible floods would now face a wind that could strip the bark from trees, the soil from the ground, and the flesh from bone. This supersonic gale would generate friction on a planetary scale, heating the air, sparking firestorms and whipping the shattered surface into an unimaginable maelstrom. The air would not simply blow, it would roar around the world in a single endless shockwave, hot and violent and absolutely lethal. Between the wall of debris, the mountain-high oceans, and the supersonic winds, the surface of the Earth in the first hour after the stop would be the closest thing to hell that physics could possibly produce. Now, you might be wondering, where does all of this energy go? Because energy never simply vanishes. It only changes form. And the Earth's rotation contains a truly staggering amount of energy. Physicists call it rotational kinetic energy. And for our planet, the number is so large it stops being meaningful to the human mind. The Earth's rotation carries something on the order of 260 septillion joules of energy. To put that in some kind of perspective, it is roughly equivalent to the energy released by detonating many billions of the largest nuclear weapons ever built, all at once. When the Earth stops, all of that energy has to go somewhere, and the answer is heat and motion. The friction of the atmosphere against the surface, the grinding of the oceans against their basins, the disintegration of everything that was flung and shattered, all of that converts the planet's rotational energy into heat. The surface of the Earth would not just be battered, it would be roasted. Temperatures would soar as the energy of the planet's lost spin poured into the crust and the air. In the most extreme analysis, there is enough energy in the Earth's rotation that releasing it suddenly could heat the surface to the point of melting rock. The instant of stopping would be, in the most literal sense, an event that could partially liquefy the surface of the world. This is the deepest reason why the sudden stop is not merely unlikely, but physically impossible without something almost as catastrophic causing it. There is no gentle hand that could grab the Earth and hold it still. To stop the Earth's spin in an instant, you would need a force so colossal, an impact or an energy release so enormous, that the stopping itself would be indistinguishable from the destruction of the planet. The cosmos has no brakes for a world. Let's slow the disaster down and walk through it moment by moment, because the sequence of events tells its own terrible story. In the first tenth of a second, the crust has stopped, but the world above it has not yet realized what has happened. Everything is still in its place, but everything is already doomed. By the end of the first full second, the displacement has begun. Loose objects have already traveled hundreds of feet eastward. A person standing in an open field has been flung the length of several football fields and is still accelerating relative to the now stationary ground, tumbling through the air at a speed no human body could possibly survive. By the end of the first few seconds, every structure on the surface that was not anchored into deep bedrock has begun to disintegrate, sheared off its foundations by the impossible sideways force. Glass, steel, concrete, wood, all of it becomes shrapnel, a churning eastward moving cloud of debris that grows denser and more violent with every passing instant. Within the first minute, the destruction has swept across entire countries. The wave of devastation does not travel exactly, because it happens everywhere at once, but the consequences cascade outward as the flung debris collides, piles up, and ignites. The friction of so much material grinding against itself and against the bare rock of the scoured crust generates tremendous heat, and fires begin to bloom across the dying landscape, fanned by the supersonic wind into firestorms beyond anything in human experience. Within the first few minutes, the oceans have entered the catastrophe in earnest. Unlike the debris on land, which is flung and then comes to rest in a churning ruin, the water of the oceans has nowhere to settle and nothing to absorb its momentum. The seas surge eastward as enormous coherent masses, climbing the eastern walls of every ocean basin and the eastern coastlines of every continent in waves of almost unimaginable height. Within minutes, the eastern shores of the Americas, of Asia, of Africa, of Australia would be inundated by water rising not to the height of a building, but to the height of a mountain. The water would not stop at the coast. It would surge inland, racing across plains and valleys at hundreds of miles an hour, drowning everything in its path for hundreds of miles before its momentum finally began to fail. And then, having spent its forward energy climbing against the land and the gravity of the planet, the water would come crashing back, recoiling westward in a second catastrophe, sloshing back and forth across the drowned continents in titanic standing waves that would take days, even weeks, to finally settle into stillness. The oceans, robbed of their spin, would behave like water in a vast bowl that someone had suddenly stopped, surging and rebounding and surging again until at last, exhausted, they found a new and unfamiliar level. Within the first hour, the surface of the earth has been transformed into a scene of total devastation. The land is scoured and burning. The oceans are climbing the continents and crashing back. The atmosphere is screaming around the world at supersonic speed, scattering the debris, fanning the fires, and grinding its energy into heat. The temperature of the air and the surface is climbing as the rotational energy of the planet pours into the system. And beneath it all, the solid Earth itself has been violently disturbed. For while the crust stopped along with the rest of the planet, the act of stopping such an enormous mass so suddenly would unleash forces deep within the Earth as well, triggering earthquakes of unprecedented magnitude all across the globe, shattering the crust, rupturing fault lines, and shaking the very bones of the planet. Volcanoes would erupt as the disturbance reached the magma chambers beneath them, adding fire and ash to the already apocalyptic scene. The first hour after the stop would not be the end of a civilization. It would be the end of a world as a habitable place, accomplished in less time than it takes to watch a television program. And even after the initial violence subsided, after the debris had settled and the oceans had found their new level and the screaming winds had finally slowed, the planet would face a second, slower catastrophe rooted deep in its own shape. Remember the equatorial bulge, the 26 miles of extra width around the planet's middle, created and sustained by the spin. With the spin gone, that bulge would no longer be supported. The solid rock of the Earth, which currently holds its slightly squashed shape because the rotation pushes it outward, would slowly begin to relax toward a more perfectly spherical form. This may sound gentle, but it would be anything but. The Earth's rigid crust does not flex easily, and the relaxation of the bulge would impose enormous stresses on the rock, stresses that the crust could only relieve through fracturing and movement. For thousands of years after the stop, the planet would groan and shudder as it slowly reshaped itself, the equatorial regions gradually sinking, and the polar regions gradually rising, as the planet sought a new equilibrium, without the outward push of rotation to hold its old form. This adjustment would drive ongoing earthquakes and volcanic activity on a scale far beyond anything our current planet experiences. A long geological convulsion lasting for ages as the Earth slowly settled into its new, rounder shape. The stopped Earth would not find peace quickly. It would spend millennia trembling, reshaping itself from the inside out, a planet in mourning for the spin it had lost. So let's be honest with ourselves about the physics for a moment, because it matters. There is no natural process, and no conceivable artificial one, that could make the Earth stop spinning suddenly. The planet has been turning for 4.5 billion years, ever since it formed from a swirling disk of dust and gas around the young sun. And that spin is a deeply conserved property, protected by one of the most ironclad laws in physics, the conservation of angular momentum. A spinning object stays spinning unless an outside force acts to slow it, and the force required to stop something as massive as the Earth in an instant is beyond anything in nature short of a collision with another planet-sized body, the kind of impact that would shatter the Earth entirely rather than simply halt its rotation. So when we ask what would happen if the Earth suddenly stopped spinning, we are asking a question that can only ever be a thought experiment, a way of probing the hidden machinery of our world by imagining its sudden absence. And that is exactly what makes it so valuable. By breaking the world in our minds, we get to see all the invisible systems that the spin has been quietly running this whole time. So having witnessed the violence of the instant, let's now do something kinder and stranger. Let's imagine that somehow, by some impossible gentleness, the Earth came to rest without the apocalypse. Let's imagine a world that is simply, peacefully, no longer spinning. Because that world, the calm world at the end of the disaster, is even more bizarre than the disaster itself. And it raises a question that turns out to be far deeper than it first appears. On an Earth that does not spin, what happens to the day? It's worth pausing to consider that the manner of the stopping changes everything about the outcome, and that there are really several different versions of this thought experiment hidden inside the single question. The first version is the one we have already lived through, the instantaneous stop, where the crust halts in a fraction of a second and inertia turns the whole surface into a killing field. That version is pure apocalypse, survived by almost no one. But imagine instead a second version, where the Earth's rotation bleeds away gradually, slowing over the course of many years or even centuries until at last the planet comes to rest. In that scenario, there would be no sudden flinging of debris, no instantaneous supersonic winds, no immediate mountain-high tsunamis, because the surface, the oceans, and the atmosphere would all slow down together, gently and gradually, never building up the catastrophic difference in speed that causes the violence of the sudden stop. Humanity might watch over generations, as the days grew longer and longer, first by minutes, then by hours, the daylight stretching out year by year as the spin slowly wound down. There would be time to prepare, time to adapt, time to migrate as the oceans began their slow creep toward the poles, and the climate began its long transformation. This gradual stop would still be a profound catastrophe, reshaping the planet's geography, climate, and magnetic field over its long course. But it would be a survivable one, a slow-motion transformation rather than an instantaneous extinction. The difference between these two versions, the sudden and the gradual, is the difference between a car hitting a wall and a car coasting to a gentle stop. And it is one of the most important distinctions in this entire scenario. The speed of the stopping determines whether it is the end of the world or merely the remaking of it. And there is even a third version, subtler still, the one that is actually happening right now, the natural slowing of the Earth over billions of years, so gradual that no living thing would ever notice it within a single lifetime, or 1,000 lifetimes, or 1,000,000. That version we will return to later, for it is the only one that is real. But the value of imagining the sudden and the gradual stops is that they show us, in fast forward, the consequences that the natural slowing would bring about only over timescales so vast they exceed the lifespan of the sun itself. By compressing eons into an instant, the thought experiment lets us see the hidden machinery of our world laid bare. Here we run into one of the most delightfully confusing consequences of stopping the spin, and it is worth taking slowly, because almost everyone gets it wrong at first. You might think that if the Earth stopped rotating, the sun would simply freeze in place in the sky, hanging motionless forever over whichever half of the planet happened to be facing it, leaving one side in eternal day and the other in eternal night. And that is almost right, but not quite, because we have forgotten something. The Earth does two different motions at once. It spins on its axis, which gives us day and night, but it also orbits the sun, traveling all the way around our star once every year. These are two completely separate motions, and stopping one does not stop the other. If we halt the Earth's spin but leave it orbiting the sun, then something remarkable happens. As the Earth slowly travels around its orbit over the course of a year, the sun would still appear to move across the sky, but agonizingly slowly. It would take the entire year, 365 days, for the sun to make one complete circuit. In other words, on a non-spinning Earth, a single day and night cycle would last one full year. 6 months of continuous daylight, followed by 6 months of continuous night. The sun would creep across the sky so slowly that you could watch it for hours and never see it move. Yet over the course of weeks, it would crawl from one horizon to the other, finally setting after half a year of light and ushering in half a year of darkness. The familiar 24-hour day would be gone forever, replaced by a year-long rhythm of endless day and endless night. Take a moment to really feel how alien that would be. Imagine watching a sunset that takes weeks to complete, the sun sinking by a fraction of a degree each day, the colors of dusk lingering for an entire month before darkness finally falls. Imagine a night that lasts half a year, the stars wheeling slowly overhead, the temperature plunging lower and lower with each passing week as the warmth of the sun stays buried below the horizon. And imagine the opposite, a daytime that never ends, the sun grinding across the sky for 6 straight months, baking the same hemisphere relentlessly, with no cool night to ever provide relief. This single change, the stretching of the day from 24 hours to a full year, would by itself remake the climate of the entire planet and threaten nearly every form of life that depends on the gentle daily rhythm of light and dark. But the year-long day is only the beginning of how strange this new Earth would become. Because once the spin is gone, the very shape of the world starts to change. The continents and the oceans, the most basic map of our planet, would slowly, inevitably, redraw themselves into something no human eye has ever seen. To understand why, we have to go back to that equatorial bulge I mentioned earlier, the fact that the Earth is not a perfect sphere. Our planet is slightly squashed, a little wider around the middle than it is from top to bottom. The difference is not small either. The Earth is about 26 miles wider through the equator than it is through the poles. And the reason for this bulge is the spin. As the planet rotates, the same outward tendency that flings water off a spinning wheel pushes the Earth's material, including its oceans, outward toward the equator, causing the middle of the planet to bulge and the poles to flatten. The oceans, being liquid and free to move, respond to this effect more dramatically than the solid rock. Right now, the spin is holding a vast amount of the world's water out around the equatorial regions, piled up there by the centrifugal tendency of the rotation. But if the spin stops, that outward push vanishes. And when it does, gravity, which has been quietly waiting this whole time, finally gets to do whatever it wants with the water. And gravity does not want the water at the equator. It wants the water at the poles. Here is the elegant, counterintuitive reason. Because the Earth bulges at the equator, the surface of the equator is actually farther from the center of the planet than the poles are. The poles, being on the flattened ends, are closer to the Earth's core, and gravity is stronger the closer you are to the center of a planet's mass. So at the poles, gravity pulls a little harder, while at the equatorial bulge, gravity is a little weaker because you're farther out. As long as the planet is spinning, the outward push of rotation balances this difference and keeps the oceans spread out. But the moment the spin stops, the balance is broken. Gravity, now unopposed, begins to pull the world's water away from the equatorial bulge and toward the poles, where its pull is strongest. The oceans would begin a slow, massive migration northward and southward, draining away from the middle of the planet and gathering at the top and bottom of the world. And this is where the new Earth reveals its truly astonishing new face. Because as the oceans drain toward the poles, the high ground around the equator emerges from beneath the retreating seas. The water would flow away from a broad band circling the planet's midsection, and in its place, a continuous, unbroken ring of dry land would rise up, a single megacontinent wrapping all the way around the world. Picture it. Where today we have the Atlantic and Pacific and Indian Oceans separating the continents, a non-spinning Earth would have a vast equatorial supercontinent, a belt of land circling the entire globe, connecting what are now separate landmasses into one enormous unbroken expanse. You could, in principle, walk all the way around the world without ever crossing an ocean, following this ring of newly exposed seafloor and existing land. And at the top and bottom of the planet, where all that displaced water had gathered, there would be 2 gigantic new oceans, a great northern ocean centered on the North Pole and a great southern ocean centered on the South Pole, each one a vast circular sea capping its respective end of the world. Scientists who have actually modeled this scenario, using detailed maps of the Earth's true surface, the height of every mountain and the depth of every ocean basin, found that the dividing line between the new land and the new seas would fall at around 30 degrees of latitude in each hemisphere. Below 30 degrees north and above 30 degrees south, stretching across the tropics and subtropics, would be the great dry supercontinent. Beyond those latitudes, reaching toward the poles, would be the two new oceans. The familiar shapes of the continents we grew up memorizing, the boot of Italy, the bulk of Africa, the long tail of South America, would be utterly transformed, merged and connected and reshaped into a planet that looks nothing like the blue marble we know. It is genuinely remarkable that we can say all of this with such confidence, and it is worth understanding how scientists arrive at these conclusions, because it is not mere guesswork. Researchers have taken detailed, real-world data about the surface of the Earth, the precise elevation of every landmass and the exact depth of every ocean basin, gathered from decades of careful measurement by satellites and ships and surveys. With that data loaded into powerful computer models, they can calculate exactly how water would flow and settle on an Earth that had stopped spinning, where the new shorelines would fall, which lands would drown, and which seafloors would emerge. They can model the gravitational field of the planet without the outward push of rotation, trace the migration of the oceans toward the poles, and produce detailed maps of the transformed world, the great equatorial supercontinent and the two polar seas, with the dividing line falling reliably around 30 degrees of latitude. This is the same kind of physics and modeling that scientists use to understand the real climate and geography of our planet and others, applied to an imaginary scenario to reveal what it would actually look like. The stopped Earth, in other words, is not a vague fantasy. It is a place that can be mapped, calculated, and visualized with real scientific rigor, a testament to how deeply we have come to understand the workings of our own world. We can break the Earth in our equations and watch precisely how it falls apart, and that ability is one of the quiet triumphs of modern science. And the consequences of this new geography would reach into every corner of life on the planet. Consider what would happen to some of the most famous places on Earth. Much of the eastern United States and Canada would be submerged beneath the new Northern Ocean, as would large parts of Europe and Russia, all of which sit at latitudes that would fall under the rising polar seas. Meanwhile, vast stretches of seafloor that have never seen sunlight, the floors of the Atlantic and Pacific in the tropics, would be lifted into the air, transformed from crushing deep-sea darkness into exposed, barren new land. Cities that today are coastal would find themselves either drowned or stranded hundreds of miles from any shore, depending on their latitude. The entire human map, the distribution of where people live and farm and build, was shaped by the current arrangement of land and sea, and that arrangement would simply cease to exist. But even this dramatic reshaping of the surface is not the most dangerous thing about a non-spinning Earth, because while the oceans are redistributing themselves, an even more profound change would be taking place in the sky and in the deep, hidden heart of the planet. The loss of the spin would do something to the Earth's defenses that no flood and no supercontinent could compare to. It would begin to dismantle the invisible shield that has protected life on this planet for billions of years. To understand this, we have to descend, in our imagination, deep beneath the surface, past the crust, past the thick rocky mantle, all the way down to the Earth's core. The center of our planet is a strange and violent place. At the very heart lies a solid inner core of iron and nickel, hotter than the surface of the sun, but kept solid by the immense pressure of the entire planet pressing down upon it. And surrounding that solid heart is the outer core, a vast ocean of liquid metal, molten iron and nickel, churning and flowing in slow, mighty currents. This swirling sea of liquid metal is the engine of one of the most important features of our entire planet, a feature so vital that without it, life as we know it could not exist. As the liquid metal of the outer core moves, Driven by heat escaping from the inner core and by the rotation of the planet, it generates electric currents. And those electric currents, in turn, generate a magnetic field. This is the geodynamo, the great hidden engine at the center of the world, and it is the source of Earth's magnetic field, the invisible force that makes compass needles point north and that surrounds our entire planet in a protective magnetic bubble. That magnetic bubble, which scientists call the magnetosphere, is far more than a curiosity for navigators. It is, quite literally, the shield that protects all life on Earth. The sun, for all its life-giving warmth, is also constantly blasting out a stream of dangerous, high-energy charged particles, a relentless gale of radiation called the solar wind. Without protection, this solar wind would be lethal. It would strip away our atmosphere over time, bombard the surface with radiation, and make the Earth as barren and exposed as Mars. And the reason it does not is the magnetosphere, the Earth's magnetic field, generated by the spinning, churning core, deflects the solar wind, channeling those dangerous particles around the planet and away from the surface, like a stone splitting a river. Every day of your life, this invisible shield has been silently absorbing and deflecting a torrent of solar radiation that would otherwise sterilize the planet. Now, here is the terrifying part. The rotation of the Earth is one of the key ingredients in keeping that magnetic shield strong and organized. The spin of the planet helps to organize the chaotic churning of the liquid core into the coherent, stable, dipole magnetic field that protects us, with a clear north and south, wrapping neatly around the globe. The Earth's rotation, through a subtle effect on the moving fluid, helps shape and align the magnetic field. Take away the spin, and you take away one of the central forces that keeps the geodynamo running smoothly and the magnetic field strong. Scientists believe that if the Earth stopped rotating, the magnetic field would likely weaken dramatically over time, possibly even collapsing in its current organized form. The churning of the core might continue, driven by heat, but without the organizing influence of rotation, the resulting magnetic field could become weak, chaotic, and far less effective at deflecting the solar wind. And as that shield faded, the consequences for the planet would be slow but devastating. The solar wind, no longer deflected, would begin to reach the upper atmosphere directly, stripping away air molecule by molecule, slowly eroding the very atmosphere that life depends on, much as scientists believe happened to Mars billions of years ago when its own magnetic field died. Dangerous radiation that is currently blocked would begin to reach the surface, raising the risk of damage to living cells, to DNA, to the entire web of life. The auroras, the beautiful northern and southern lights that currently dance only near the poles where the magnetic field channels solar particles into the atmosphere, would change entirely, perhaps appearing in strange new places or fading away as the field that creates them weakened. The loss of the magnetic field would not be a sudden death like the floods and the winds, but a slow strangulation, a gradual exposure of the planet to the harsh radiation of space over thousands and millions of years. The Earth would become, in time, a more hostile and irradiated world, its protective bubble punctured by the simple act of stopping its spin. To understand just how serious the slow death of the magnetic field would be, we do not have to imagine. We only have to look at our planetary neighbor, Mars. Billions of years ago, Mars was a very different world than the cold, dry, barren desert we see today. The evidence written into its rocks tells a story of a young Mars with rivers, lakes, perhaps even oceans, a thicker atmosphere and the warmth and water that might have made it hospitable to life. Mars, in its youth, may have looked something like a smaller, redder version of the early Earth. But Mars had a fatal weakness. It is a smaller planet, and its core cooled faster than Earth's. As that core cooled and its churning slowed, the dynamo that had generated the Martian magnetic field weakened and then died. And once the magnetic shield was gone, the solar wind, the relentless stream of charged particles from the sun, began to strip away the Martian atmosphere, molecule by molecule, over hundreds of millions of years. With its protective field gone and its atmosphere bleeding away into space, Mars cooled, dried out, and became the frozen, irradiated, nearly airless world we know today. Its rivers reduced to dry channels, its oceans vanished, its surface exposed to a level of radiation that would be lethal to most life. Mars is, in a very real sense, a preview of what awaits a planet that loses its magnetic shield. It is the ghost of a world that might have been alive, killed in slow motion by the death of its protective field. And on a non-spinning Earth, with its weakened and disorganized magnetic field, we would face the beginning of that same long process, the slow stripping of our atmosphere and the gradual irradiation of our world. We would not become Mars overnight, or even over thousands of years, but we would have set our foot on the same dark road, watching our defenses crumble against the harsh radiation of the sun and the deeper cosmos beyond. The difference between a living world and a dead one can come down to something as seemingly remote as the churning of molten metal in the core, organized by the gentle, ceaseless turning of the planet. There is a further wrinkle worth considering, because the magnetic field protects us not only from the sun, but from the wider galaxy as well. Beyond the solar wind, the Earth is constantly bombarded by cosmic rays, extraordinarily high-energy particles that come streaming in from distant exploding stars and the violent depths of the cosmos. The magnetic field, together with the atmosphere it protects, shields the surface from much of this cosmic radiation, keeping the dose that reaches living things low enough that life can flourish without being constantly damaged. Weaken the magnetic field, and more of these cosmic rays would reach the surface, raising the background radiation that every living cell must endure. Over long periods, this elevated radiation would increase the rate of genetic mutation, damage living tissue, and place every organism under a new and constant stress. Life might adapt, evolving more robust mechanisms to repair the damage, but it would be life lived under a harsher sky, on a planet whose ancient shield had been compromised by the loss of its spin. The protective magnetosphere, generated in the deep core and shaped by the rotation, turns out to be one of the great unsung heroes of our habitable world, and its slow failure would be one of the most consequential, if least visible, results of the stopped Earth. But let's come back up from the core, back to the surface, back to the world of weather and wind and water, because there is another invisible system that the spin has been quietly running, one that touches your life every single day even if you've never heard its name. It is called the Coriolis effect, and it is the reason that storms swirl, that winds curve, and that the weather of the entire planet behaves the way it does. The Coriolis effect is a consequence of trying to move across the surface of a spinning sphere. Because different parts of the Earth move at different speeds, fastest at the equator and slowest near the poles, anything that travels a long distance across the surface, like a mass of air or water, appears to curve rather than move in a straight line. In the northern hemisphere, moving things curve to the right. In the southern hemisphere, they curve to the left. This is why hurricanes and cyclones spin, rotating in opposite directions on either side of the equator. It is why the great wind belts of the planet, the trade winds and the westerlies, blow in their characteristic directions. It is why ocean currents trace their vast curving paths around the globe. The entire circulation of the atmosphere and the oceans, the engine that distributes heat from the equator to the poles and drives the weather, is shaped and steered by the Coriolis effect, which exists only because the Earth spins. So what happens to the weather when the spin stops and the Coriolis effect disappears? Everything we know about global wind patterns would be erased and rewritten. Without the Coriolis effect, the winds would no longer curve. The trade winds, the westerlies, the polar easterlies, all the familiar bands of global wind would vanish. Hurricanes as we know them, with their characteristic spin, could no longer form in the same way, because the rotation that organizes them into spinning storms would be gone. But this does not mean the new Earth would be calm. Far from it. On a non-spinning Earth, the day-night cycle is no longer 24 hours but a full year, which means one hemisphere would be baking under 6 months of continuous sunlight, while the other froze under 6 months of darkness, creating temperature differences between regions more extreme than anything our current planet experiences. Air would rush from the brutally hot, sunlit regions toward the frigid, dark ones, and from the scorching equatorial supercontinent toward the cold polar oceans. Without the Coriolis effect to deflect them, these winds would blow in great straight-line rivers, flowing directly from hot to cold, from high pressure to low pressure, in patterns utterly unlike our current weather. The simple north-south flow of air, undisturbed by the curving force of rotation, would create a global circulation pattern that no meteorologist has ever observed, driven by the savage temperature contrasts of a world with a year-long day. Some regions might become locked in perpetual scorching winds, others in endless frozen calm, the entire familiar dance of weather replaced by something stark and strange and new. There is a subtle question hidden here about the seasons, and it is worth untangling. On our present Earth, the seasons are caused not by the spin, but by the tilt of the planet's axis. The fact that the Earth leans about 23.5 degrees to one side as it orbits the Sun. This tilt means that as the Earth travels around its orbit, first one hemisphere and then the other leans toward the Sun, giving us summer and winter. If the Earth stopped spinning but kept this axial tilt, the seasons would not simply vanish, but they would merge in a strange way with the new year-long day. The slow movement of the sun across the sky over the course of the year, combined with the tilt, would create a complex pattern of light and heat unlike anything we know. The sun tracing a slow, looping path through the sky over the year, climbing higher and sinking lower in a way that blended the old idea of seasons with the new reality of a day that lasted an entire orbit. For some locations, the sun might circle near the horizon for long stretches, neither fully rising nor fully setting, casting an endless eerie twilight. For others, it might climb high overhead and bake the land for months before slowly sinking away into the long night. The familiar four seasons, spring and summer and autumn and winter, would dissolve into something far more extreme and far stranger. A single great cycle of light and dark stretched across the year and modulated by the tilt of a world that no longer turned upon its axis. And the atmosphere, once the initial violence had passed and the air had finally come to rest along with the rest of the planet, would settle into a new and unfamiliar equilibrium of its own. The total amount of air would be the same, but its behavior would be transformed. Without the spin to drive the great circulating bands of wind, and with the savage temperature contrast between the endlessly sunlit and endlessly dark hemispheres, the air would organize itself around the flow of heat from the hot side to the cold side of the planet. Vast, slow rivers of air would move from the baking day hemisphere toward the frozen night hemisphere high in the atmosphere, then return along the surface. A single planet-spanning circulation utterly unlike the multiple bands of wind that currently wrap our spinning world. In the coldest regions, over the polar oceans during their long nights, the air might grow bitterly, brutally cold, and snow and frost would blanket the frozen landscapes for months on end. In the hottest regions, on the dayside interior of the supercontinent, the superheated air would rise in great columns, driving fierce surface winds inward to replace it. The atmosphere would still protect the surface, still provide the air to breathe, but its grand patterns of motion would be redrawn entirely. A new and alien weather machine running on the savage temperature differences of a world with a year-long day. To stand on that transformed Earth and feel the wind would be to feel a wind that obeyed laws our planet has never known. And what of the temperatures themselves? This is perhaps where the new Earth would be most hostile to the kind of life that currently thrives here. Consider the equatorial supercontinent, that great ring of land circling the planet's midsection, baking under the slow crawl of the sun. During its 6-month day, the heart of this supercontinent, far from any ocean to moderate the temperature, would heat to extremes. Deserts already become brutally hot under a single 12-hour day. Now imagine the same ground absorbing sunlight continuously for 6 months, with no cool night to ever release the accumulated heat. The interior of the supercontinent could become hotter than the most extreme deserts on Earth today, a landscape of cracked, scorched rock under a sun that never sets, far too hot for most familiar life to endure. And then, when the 6-month day finally ended and the long night began, that same baked landscape would plunge into a deep freeze, the temperature dropping week after week through the long darkness, until the same desert that had been an oven became a frozen wasteland. The swings between the endless day and the endless night would be savage, a planet of climatic extremes that would make survival in the continental interiors almost impossible for anything that could not burrow, hibernate, or migrate vast distances to follow the gentler temperatures. And consider what the night itself would become, not just the cold and the darkness, but the sky overhead. On our spinning Earth, the stars appear to wheel across the night sky over the course of a few hours, rising in the east and setting in the west just as the sun does, because it is the Earth's rotation, not the stars' motion, that carries them across our view. Anyone who has watched a long-exposure photograph of the night sky has seen this turned into beautiful arcs, the star trails circling around the celestial poles as the planet spins beneath them. But on a non-spinning Earth, this nightly procession would cease. The stars would no longer rise and set over the course of hours. Instead, during the long 6-month night, the same stars would hang almost motionless in the sky, drifting only slowly over the course of weeks as the Earth crept along its orbit around the sun. You could go to sleep beneath a particular constellation and wake hours later to find it had barely moved. The familiar rhythm of the rotating sky, which has guided navigators and inspired astronomers and poets for all of human history, would be replaced by a strange, frozen stillness, the heavens hanging nearly fixed above a world that no longer turned. Sailors who once steered by the wheeling stars, farmers who once read the seasons in the rising of particular constellations, all the ancient human relationships with the night sky would be overturned. The cosmos itself would seem to have stopped, mirroring the stillness of the world below. And during the long 6-month day, of course, there would be no stars at all, only the relentless, unmoving sun grinding its slow path across a sky that never darkened. The night would become a season rather than a part of each day, a half-year of darkness in which the unchanging stars presided over a frozen, waiting world. So where, on this transformed world, could life survive? The answer points us to the coastlines and to the boundaries, the in-between places. Water has a remarkable ability to absorb and store heat, warming and cooling far more slowly than land. The two great polar oceans, vast bodies of water capping the top and bottom of the world, would act as enormous reservoirs of thermal stability, their temperatures changing far more gradually than the land through the long cycles of day and night. The coasts of these new oceans, the shores where the equatorial supercontinent met the polar seas, would be the most temperate places on the new Earth, moderated by the water, spared the worst extremes of the baking continental interiors. It is along these coastlines, in a band somewhere around the boundary between the land and the polar seas, that life would most likely cling on, finding the narrow zones where temperatures stayed within the range that living things can tolerate. Life is extraordinarily resilient and adaptable, and given enough time, it would surely find ways to survive in the habitable margins of even this radically altered planet. But the lush, temperate, broadly habitable world we know, the world of forests and grasslands and gentle seasons spread across vast portions of the globe, would be gone, replaced by a planet of harsh extremes with only narrow ribbons of livable land. Now let us turn to the most human question of all. What would happen to us? What would happen to people, to civilization, to the more than 8 billion human beings currently living on this spinning planet? If we are talking about the sudden stop, the instantaneous halt that flings everything eastward at 1,000 miles an hour, then the answer is brutally simple. Almost no one would survive the first few seconds. The supersonic debris, the world-spanning tsunamis, the planet-scouring winds, and the searing heat would wipe out the overwhelming majority of life on Earth in the first moments and hours. Only those few people near the poles, where the rotational speed was lowest, might survive the initial instant, and even they would soon face the floods, the failing climate, the dying magnetic field, and the collapse of every system that modern civilization depends on. Picture those rare survivors, perhaps a handful of researchers at a polar science station, or the inhabitants of some far northern settlement, who happened to be in the one place on Earth where the ground was barely moving when the world stopped. They would have felt a jolt, a sudden ground heave, perhaps a strange shifting of the world around them, but they would have lived through the instant that killed almost everyone else on the planet. And then they would look out at a dying world. The skies would darken with the dust and ash thrown up by the global earthquakes and the firestorms raging across the lower latitudes. The temperature would begin its wild new swings. The seas would be heaving and crashing as the displaced oceans surged toward them, for the poles are exactly where all that water would eventually gather. Within days or weeks, even these survivors would likely be overwhelmed, drowned by the migrating oceans, or starved as every supply chain and food source on Earth ceased to exist. To survive the first second only to face the slow death of the world afterward would be a cruel fate indeed, a brief reprieve before the inevitable. There would be no help coming, for there would be no one left to send it. The sudden stop would leave behind not survivors so much as the last witnesses, granted a few final days to behold the end of the world they had known. There would be no rescue, no recovery, no rebuilding. The sudden stop would be, for all practical purposes, an extinction event, one of the most complete and violent ends that the Earth could possibly experience. Human civilization, with all its cities and cultures and accumulated knowledge, would be erased in less time than it takes to read this sentence. But suppose, in our kinder thought experiment, the Earth came to rest gently, sparing us the initial apocalypse. Suppose humanity survived the transition and found itself living on the slow, transformed, year-long day Earth. Could civilization endure? It would be one of the greatest challenges our species has ever faced. The reshaping of the oceans would drown many of the world's great cities and strand others far inland, displacing billions of people and destroying the agricultural lands that feed the planet. The crops we depend on are finely tuned to the rhythm of our current days and seasons, and they could not survive a year-long cycle of 6-month days and 6-month nights without complete reinvention of how and where we grow food. The savage temperature extremes would render vast regions uninhabitable. The weakening magnetic field would expose us to rising radiation. The familiar rhythms that govern human biology, our sleep, our hormones, our very sense of time, all built around the 24-hour day, would be thrown into chaos by a world where the sun rose once a year. Humanity might survive, clustered along the temperate coastlines of the new polar oceans, sheltering from the radiation, farming under artificial lights or in the narrow temperate zones, but it would be a transformed existence, a desperate adaptation to a world that had become fundamentally hostile to the life that evolved upon it. The civilization that emerged on the other side, if any did, would bear little resemblance to the one we know. Consider, for a moment, the sheer scale of human upheaval this would represent, even in the gentle version where people survived the transition. The great majority of humanity lives near coastlines, in the great port cities and river deltas and coastal plains that have been the cradles of civilization for thousands of years. Every one of those settlements would be rendered meaningless by the redistribution of the seas, either drowned beneath the new oceans or stranded in the dry interior of a continent that had not existed before. The farmland that feeds the world, much of it lying in temperate zones at latitudes that would now fall under the polar oceans or bake in the supercontinental interior, would largely vanish. The infrastructure of modern life, the ports and the shipping lanes, the fisheries and the irrigation systems, all of it tied to the current arrangement of land and sea, would become useless. Humanity, if it survived at all, would have to begin again, migrating to the narrow temperate zones along the new coastlines and learning to live on a planet whose every fundamental feature had been rewritten. It would be the greatest migration and the greatest reinvention in the history of our species, dwarfing every war, every plague, every upheaval that has ever come before. And yet, if any species could find a way to endure such a transformation, it might be ours, precisely because we are the one species that does not rely on biological evolution alone to adapt. We have technology. We have agriculture that can be reinvented, artificial light that can mimic the missing day, engineering that can build shelters against the radiation and the temperature extremes. On a stopped Earth, perhaps humanity would build great enclosed cities along the temperate coasts, growing food under artificial lights tuned to the rhythms our crops still needed, sheltering from the heightened radiation behind walls and roofs, riding out the 6-month nights with stored energy, and the 6-month days behind reflective shields. Perhaps we would learn to harness the savage temperature differences between the baking supercontinent and the frozen polar oceans, drawing power from the very extremes that made the planet so hostile. It would be a diminished and embattled existence compared to the abundance we enjoy now, a humanity clinging to engineered refuges on a transformed world, rather than spreading freely across a gentle and generous planet. But it is not impossible to imagine that human ingenuity, the same ingenuity that has let us survive in deserts and on ice caps, and even in the vacuum of space aboard our orbiting stations, might find a way to persist even here. We are, after all, the species that adapts not by waiting for our bodies to change, but by changing the world around us. And even a stopped world might not be entirely beyond our reach. It is worth pausing here to reflect on just how much of our world, our daily lives, our biology, and our civilization rests upon something as seemingly simple as the rotation of the planet. We take the spin for granted. We never feel it, never see it, never give it a moment's thought. And yet, as we have seen, that quiet, ceaseless turning is the foundation of nearly everything. It gives us the day and the night, the basic rhythm that every living thing on Earth has evolved to follow. It shapes the very form of the planet, holding the oceans in their basins and the continents in their familiar places. It powers, in part, the magnetic shield that protects us from the deadly radiation of space. It steers the winds and the ocean currents, driving the weather and distributing the warmth of the sun across the globe. It is the invisible hand behind the seasons, the storms, the tides of air and water that make the Earth a living world. The spin is not a minor detail. It is one of the great load-bearing pillars of our entire existence, and we never even notice it is there. That is, perhaps, the deepest lesson hidden inside this impossible thought experiment. By imagining the Earth stopping, we come to appreciate just how delicately balanced and interconnected our planet truly is. Every system depends on every other. The spin shapes the magnetic field, which protects the atmosphere, which holds the climate, which supports the life, which has adapted to the rhythm of the spin. Pull out a single thread, and the entire tapestry begins to unravel in ways we could never have predicted. The Earth is not a static stage on which life merely happens to occur. It is a dynamic, spinning, churning, breathing system, every part of it in motion, every part of it connected, every part of it essential. We are not passengers on a still and solid world. We are riders on a spinning top, surrounded by invisible forces that we owe our very lives to, and that we almost never stop to consider. Let's go back for a moment to the deep machinery of the planet and dwell on something we touched only briefly, because it deserves a closer look. The Earth's rotation is not just spinning idly. It is doing work, constantly, on the great fluid systems of the planet. And nowhere is this more profound than in the slow circulation of the world's oceans. The oceans of the Earth are not a still bathtub. They are in constant motion, vast rivers of water flowing around the globe in patterns called the Great Ocean Conveyor Belt, carrying warm water from the tropics toward the poles and cold water from the poles back toward the equator. This circulation is one of the most important regulators of the Earth's climate, moving immense quantities of heat around the planet and keeping the temperatures of distant regions within livable bounds. Western Europe, for example, is far warmer than it would otherwise be at its latitude, kept mild by the warm waters that the ocean currents deliver from across the Atlantic. And the Coriolis effect, born of the planet's spin, is one of the central forces that shapes and steers these mighty currents, deflecting them into the great curving gyres that span the oceans. Stop the spin, and you do not just change the weather. You disrupt the deep circulation of the oceans themselves, the slow heartbeat of the global climate, with consequences that would ripple through every ecosystem on the planet. And consider, too, the question of the tides. Right now, the rise and fall of the oceans, the daily rhythm of high tide and low tide that shapes the lives of coastal creatures and the patterns of shipping and fishing, is driven primarily by the gravitational pull of the moon, and to a lesser extent the sun, as the Earth rotates beneath them. As our planet spins, each coastline passes through the bulges of water that the moon's gravity raises in the ocean, giving us 2 high tides and 2 low tides each day. On a non-spinning Earth, the tides would be transformed almost beyond recognition. The moon would still orbit the Earth, but the rapid daily cycle of tides driven by the Earth's rotation would be gone. Instead, the tidal patterns would be governed by the much slower motion of the moon around the Earth and the Earth around the sun, stretching the rhythm of the tides into something utterly unlike the familiar twice-daily pulse that has shaped coastal life for as long as there has been life on the shore. The intertidal zone, That rich band of life between the high and low tide marks where so many creatures thrive would be reshaped entirely. Another casualty of the stopped spin, another ecosystem upended by the loss of a rhythm we barely notice. There is something almost poetic in realizing how many of these rhythms our biology has woven into itself over billions of years of evolution. Deep in the cells of nearly every living thing on Earth, there is a kind of internal clock, a biological mechanism that tracks the passing of the day and tunes the organism's activity to the rhythm of light and dark. We call it the circadian rhythm, and it governs when we sleep and when we wake, when our bodies release certain hormones, when our temperature rises and falls, when we feel hungry and when we feel tired. This clock is not a recent invention. It is ancient, present in some form in creatures from the simplest bacteria to the largest mammals, all of them having evolved over countless generations to anticipate and synchronize with the 24-hour cycle of the spinning Earth. It is one of the deepest and most universal adaptations of life on this planet, a testament to just how fundamental the daily rhythm of the spin has been to the evolution of living things. And on a non-spinning Earth, with its year-long day, this ancient clock would be left ticking against a rhythm that no longer existed. Plants that flower in response to the changing length of days, animals that hunt by night or by day, the entire intricate timing of the living world, all of it would be thrown into confusion, forced either to adapt to an utterly new rhythm over countless generations or to perish. The circadian clock, perfected over billions of years, would suddenly be telling the wrong time on a planet where time itself had been redefined. And it is not only our biology that is built around the day. Our entire civilization, every culture that has ever existed, has organized itself around the rhythm of the spinning Earth. The day is the fundamental unit of human time, the beat to which all of society marches. We wake and sleep by it. We schedule our work and our rest by it. We mark the passage of our lives in days and weeks, units that exist only because the Earth turns. Our religions, our holidays, our calendars, our very sense of time and history are all built upon the foundation of the daily cycle of light and dark. Clocks, those ubiquitous instruments that govern modern life, exist to divide the day into manageable pieces. The working day, the school day, the very concept of a daily routine, all of it assumes a world that turns once every 24 hours, bringing morning and evening in their familiar succession. On a world where the day lasted a year, this entire architecture of human time would collapse. What would a workday mean when the sun did not set for 6 months? How would you schedule sleep, organize society, mark the passage of time, when the great natural clock of the rising and setting sun had slowed to a single beat per year? Humanity would have to invent an entirely new relationship with time, abandoning the deep, intuitive rhythm that has structured human life since before recorded history. We would keep our clocks, perhaps, ticking out artificial 24-hour days against a sky that no longer cooperated, living by a rhythm that existed only on our instruments and no longer in the world around us. A strange disconnection between the time we kept and the time the planet showed. It would be one more way in which the loss of the spin would unmoor us from the most basic certainties of existence, severing the ancient bond between human time and the turning of the world that has held since the very dawn of our species. And there is a quieter, more modern dependency that almost no one thinks about, woven invisibly into the technology of our daily lives. High above our heads, a fleet of satellites circles the planet, and a great many of them, the ones we rely on for television, for communications, for weather observation, occupy a very special kind of orbit called geostationary. These satellites are placed at exactly the altitude where their orbital speed matches the rotation of the Earth beneath them, so that they appear to hover motionless over a single fixed point on the surface, allowing the dishes on our rooftops to point at one spot in the sky and never move. That entire arrangement, the foundation of much of modern satellite communication, exists only because the Earth spins at its particular rate. Stop the spin, and every geostationary satellite would instantly cease to be stationary. They would continue circling the planet at their orbital speed, but the ground beneath them would no longer be turning to keep pace, so they would appear to drift across the sky and pass over different parts of the world, no longer hovering above their assigned locations. The careful choreography of our communications infrastructure would be thrown into disarray, dishes pointing at empty sky, signals lost as the satellites wandered out of position. Even the systems we use to find our way, the constellations of navigation satellites that let a phone in your pocket pinpoint your location anywhere on Earth, depend on precise models of the planet's rotation built into their calculations. Stop the spin, and those calculations would be wrong. The maps and the positioning thrown off until everything could be recomputed for a world that no longer turned. It is a small thing next to the drowning of continents and the dying of the magnetic field, but it is a vivid reminder of just how thoroughly the spin is built into the machinery of our civilization, down to the satellites overhead and the device in your hand. And yet, if there is one thing the long history of life on Earth has taught us, it is that life is almost unfathomably resilient and inventive given enough time. The planet has endured catastrophe after catastrophe across its billions of years. Asteroid impacts that darken the skies, volcanic eruptions that poison the oceans, ice ages that buried continents, and mass extinctions that wiped out the overwhelming majority of all species then alive. And every single time, life has not merely survived but eventually flourished anew, radiating into the empty spaces left by the dead, evolving extraordinary new forms suited to the changed world. So while the stopping of the spin would surely drive countless species to extinction, unable to adapt quickly enough to the year-long day and the savage temperature swings and the reshaped geography, it is just as certain that, given enough time, life would rise to meet the challenge. Over hundreds of thousands and millions of years, new forms would evolve, exquisitely adapted to the strange new rhythms of the stopped planet. Imagine creatures evolved for a 6-month day, plants that store the energy of half a year of continuous sunlight to survive half a year of darkness, animals that undergo enormous migrations following the gentle temperatures around the planet, or that hibernate through the long night and reawaken with the slow dawn. Imagine ecosystems built along the temperate coasts of the new polar oceans, entirely new webs of life woven around the new conditions. The Earth would not be lifeless. It would simply be home to life of a kind we cannot quite picture, life shaped by a sun that rose once a year and a world that did not turn. Evolution would find a way, as it always has, filling the strange new planet with strange new living things over the slow march of geological time. The forms might be unrecognizable, but the stubborn, creative, relentless force of life itself would carry on. This is perhaps the most hopeful note in the entire scenario, and it is worth holding onto. The stopping of the spin would be a catastrophe almost beyond imagining for the life that exists now, for us, and for the millions of species that share the planet with us, all of us shaped by and dependent upon the world as it currently turns. But life as a phenomenon, life as the deep and persistent property of this remarkable planet, would endure. The Earth has been a living world for nearly 4 billion years, through changes more dramatic than most people ever realize, and the loss of its spin, devastating as it would be one more chapter rather than the final page. Some forms would die, and new forms would arise, and the great experiment of life would continue, rewritten but unbroken, on a planet that had become something new. There is a strange comfort in that, a reminder that life is bigger and more durable than any single arrangement of the world, even one as fundamental as the spin. Let's return once more to that opening image, the one I asked you to hold on to. You, sitting still, moving faster than a bullet. It is, I think, one of the most quietly astonishing facts about being alive. We move through the universe at tremendous speed in many ways at once. The Earth spins, carrying us at up to 1,000 miles an hour at the equator. The Earth orbits the Sun, dragging us along at 67,000 miles an hour through space. The Sun itself, with all its planets, orbits the center of our galaxy at hundreds of thousands of miles an hour, and the galaxy itself drifts through the vast emptiness of the cosmos. We are, all of us, hurtling through space at speeds the human mind can barely fathom, and we feel none of it, because all of it is smooth and steady and shared by everything around us. The stopping is the only thing we would ever feel, and the stopping, as we have seen, would be the end of nearly everything. There is a strange comfort in that thought, and a strange terror too. Our safety, our very lives, depend on the constancy of the motion, on the unbroken steadiness of a spin that has continued without pause for 4.5 billion years and that will, by every law of physics we know, continue for billions of years to come. For the spin is not going to stop. Let me say that clearly, because after dwelling so long on the catastrophe, it is worth grounding ourselves again in reality. The Earth's rotation is one of the most stable and well-protected features of our planet, guarded by the conservation of angular momentum, the same physical principle that keeps a spinning figure skater turning and a child's top upright. There is no mechanism in nature that could stop the Earth suddenly, and no force we know of, short of a planet-destroying collision, that could do it at all. The Earth's spin is, in fact, slowing, but at a pace so gradual that it is almost beyond comprehension. The gravitational interaction between the Earth and the Moon, the same interaction that raises the tides, very slowly transfers energy from the Earth's rotation to the Moon's orbit, causing our planet's spin to decelerate by a tiny fraction each year. The length of a day is increasing by roughly 0.02 of a second every century. Hundreds of millions of years ago, in the age of the early dinosaurs and before, the day was noticeably shorter, perhaps only 22 or 23 hours long, and the Earth spun faster than it does today. Over the immense span of geological time, the day has been gradually lengthening, and it will continue to do so, but at a rate so slow that it would take billions upon billions of years to make any dramatic difference. Far longer than the sun itself will continue to shine. So the sudden stop will never happen. The spin is safe. And that, perhaps, is the most reassuring conclusion of this entire dark journey. It's worth asking while we're here where the spin came from in the first place, because the answer connects our planet's rotation to the very birth of the solar system. Our sun and all its planets formed about 4.5 billion years ago from a vast cloud of gas and dust drifting in space. As gravity pulled this cloud together, it began to collapse inward, and like a figure skater pulling in their arms, the collapsing cloud spun faster and faster, flattening into a great rotating disk with the young sun forming at its center. Everything that condensed out of that spinning disk, including the Earth, inherited its rotation, born already turning from the swirling material that formed it. So the Earth's spin is not something that was added later. It is a birthright, a piece of the original motion of the solar nebula itself, preserved and carried forward across billions of years by the conservation of angular momentum. When you watch the Earth turn, you are watching, in a sense, the echo of the spinning cloud that gave birth to the sun and all its worlds, a motion 4.5 billion years old, passed down to us from the dawn of the solar system. There is something profound in that, the realization that the daily turning of our world is a direct inheritance from the moment of its creation, an unbroken thread of motion reaching back to the very beginning. And the moon, our constant companion, has been entangled with the Earth's spin from very early on. The leading explanation for the moon's origin is that, not long after the Earth formed, a Mars-sized world collided with the young Earth in a catastrophic impact, blasting an enormous quantity of material into orbit, which then coalesced to form the moon. That ancient collision did more than create the moon. It also gave the Earth an extra kick of spin and tilted its axis, setting up the rotation and the axial tilt that would go on to shape our days and our seasons for billions of years. So the very spin we have been imagining stopping was, in part, a gift from one of the most violent events in our planet's history, a colossal collision in the deep past, whose consequences we still live by every single day. And ever since that impact, the moon and the Earth have been locked in their slow gravitational dance, the moon gradually drifting away and the Earth's spin gradually slowing, the two bound together across the eons in a relationship that will outlast civilizations and species and continents alike. But the slow stop, the natural deceleration over the eons, is a fascinating story in its own right. And it tells us something about the deep history and far future of our world. Long ago, when the Earth was young, the day may have been as short as 6 hours, and the planet spun dizzyingly fast compared to today. The moon, which formed in the aftermath of a colossal collision early in the Earth's history, has been gradually pulling away from us and slowing our spin ever since, in a delicate gravitational dance that has played out over billions of years. Each year the moon drifts a few centimeters farther from the Earth, and each year the Earth's spin slows by an imperceptible amount, the two locked in a slow exchange of energy and momentum that will continue for as long as they orbit together. Over unimaginable stretches of future time, this process would, in principle, continue until the Earth's day grew longer and longer, eventually matching the time it takes the moon to orbit, at which point the Earth and moon would become locked facing one another, the same way the moon already always shows us the same face. But this final state lies so far in the future, tens of billions of years away, that the sun will have died and the Earth itself will likely have been destroyed long before it could ever come to pass. The natural slowing of the spin is real, but it operates on timescales that dwarf the entire history of life, the entire age of the universe so far. It is a reminder that even the most permanent-seeming features of our world are, on the grandest scales of time, slowly changing. So when we ask what would happen if the Earth suddenly stopped spinning, we are really asking a question about everything. We are asking about inertia and momentum, about the violence locked inside motion. We are asking about the shape of the planet, the dance of land and sea, the hidden engine in the core and the invisible shield in the sky. We are asking about the wind and the weather, the tides and the currents, the rhythm of day and night that beats inside every living cell. We are asking about the past, when the day was shorter and the Earth spun faster, and about the future when it will spin slower still. We are asking in the end about how astonishingly, improbably, delicately fortunate we are to live on a world where all of these systems work together in such perfect, life-giving harmony. A harmony we never notice, never question, and never thank, because it has always simply been there, turning beneath our feet. The next time you watch a sunset, I hope you will think about this. That slow descent of the sun toward the horizon, the colors spreading across the sky, the gentle arrival of evening, all of it is the spin of the planet made visible. You are not watching the sun move. You are watching the Earth turn, carrying you away from the light, at 1,000 miles an hour into the shadow of the planet's far side, into the night. And when the sun rises again in the morning, that too is the spin, bringing you back around to face the light once more, as it has done every single day of your life, and every day for billions of years before you were born. The sunrise and the sunset are the heartbeat of the spinning world, the visible pulse of the motion that gives us our days, our nights, our weather, our protection, our very lives. They are the most ordinary thing in the world and the most extraordinary all at once. We have imagined the unimaginable. We have stopped the world and watched it shatter, watched the oceans climb into the sky and the winds scour the continents and the great machinery of the planet grind to a halt. We have seen the world remade in stillness, its oceans gathered at the poles, its lands joined into a single scorched ring, its days stretched to a year, its shield against the radiation of space slowly fading. We have followed the consequences from the first violent instant to the slow transformation of the centuries that would follow. And in doing so, we have seen our own world more clearly than we ever could by simply looking at it as it is. For sometimes the only way to truly understand something is to imagine its absence, to take it away in the laboratory of the mind and watch what falls apart. The spin of the earth is one of those quiet, essential things, a foundation so deep and so reliable that we have built our entire existence on top of it without ever once acknowledging it was there. To imagine it stopping is to suddenly see it, to feel for the first time the immense, steady, life-giving power of the turning world beneath us. And so we arrive back where we began, with you, sitting still, racing through space faster than a bullet, riding the spinning surface of a world that has never once, in all its long history, stopped to let you off. You feel nothing, because the motion is perfect and constant and shared by all the world around you. And in that nothing, in that perfect unfelt smoothness, lies the whole secret of your safety and your life. The world spins, and because it spins so steadily, you are free to live, to sleep beneath the turning stars, to wake to the rising sun, to walk and run and love and dream upon the surface of a planet hurtling through the dark at impossible speed. The spin asks nothing of you. It demands no thanks, no attention, no acknowledgement. It simply turns day after day, year after year, age after age, carrying all of life along with it through the endless night of space. So the next time someone tells you that nothing in your life is certain, you can smile and think of the one thing that is. The world is spinning. It has always been spinning. And for as long as you live and for billions of years beyond, it will be spinning still. That, in the end, is the quiet miracle that this terrifying thought experiment reveals. Not the horror of the stopping, but the wonder of the turning. The world spins, and so we live. And it is not going to stop. There is one final thread worth pulling, because it brings everything together in a way that is both humbling and strangely beautiful. Everything we have explored, the inertia that would fling us eastward, the oceans that would drown the eastern shores, the winds that would scour the world, the supercontinent that would rise from the retreating seas, the magnetic shield that would slowly fade, the year-long day that would bake one hemisphere and freeze the other. All of it traces back to a single fact, almost laughably simple when you state it plainly. The Earth is spinning. That one fact, that one rotation completing itself roughly every 24 hours, is the hidden root from which all of these consequences grow. It is a perfect illustration of one of the most profound truths about our universe, that the deepest and most far-reaching effects often spring from the simplest underlying causes. A spinning ball of rock and metal and water, turning quietly in the void, gives rise to days and nights, to seasons and storms, to tides and currents, to a protective magnetic field, to the very shape of the continents and the distribution of the seas, to the rhythms encoded in every living cell. Remove that single simple cause, and the entire elaborate structure of consequences comes tumbling down. It is enough to make you look at the spinning earth, this most ordinary of things, with a kind of awe. We began with a hook, with the strange and arresting idea that you are moving faster than a bullet while sitting perfectly still. And I hope that by now that idea has transformed in your mind from a mere curiosity into something deeper, a doorway into understanding just how extraordinary the ordinary really is. The world you walk through every day, the solid ground, the steady sky, the reliable rising and setting of the sun, all of it rests upon a foundation of motion so vast and so constant that it has become invisible to us. We have spent this entire journey making that invisible foundation visible, by imagining what would happen if it were taken away. And what we have found is that the Earth's spin is not a minor feature of our world, but one of its absolute pillars, woven into the climate, the geography, the magnetic shield, the oceans, the atmosphere, and the deepest biology of every living thing. To understand the spin is to understand the Earth itself, and to understand how delicately and improbably suited our planet is to the life that flourishes upon it. So let me leave you with this. The universe is full of worlds. Astronomers have now discovered thousands of planets orbiting other stars, and there are surely billions upon billions more scattered throughout our galaxy and beyond. Some of those worlds spin quickly, some spin slowly, and some, locked by the gravity of their stars, do not spin relative to their suns at all, frozen with one face in eternal day and the other in eternal night, much like the still Earth we imagined. Each of these worlds is shaped by its rotation, or its lack of one, in ways that determine whether it could ever host life, and what kind of life that might be. Our Earth, with its particular spin, its particular tilt, its particular dance with its moon and its sun, occupies a kind of sweet spot, a set of conditions so finely balanced that complex, intelligent life was able to arise and flourish and eventually look up at the stars and wonder. The spin is part of what makes Earth home. And while we have imagined in vivid and sometimes terrifying detail what it would mean for that spin to stop, the truer and more lasting takeaway is gratitude and wonder for a turning world that asks nothing of us and gives us everything. The Earth spins, we feel nothing, and in that perfect, unfelt, ceaseless motion lies the foundation of every sunrise we will ever see. Hold on to that the next time you watch the light return to the morning sky. You are riding a spinning world through the cosmos, and it is one of the most beautiful rides imaginable. May it never stop, and it never will.